All right. Yeah. Well, let's formally get this going here. So, yes, it is my pleasure to be joined by Alex and Rich to talk about this really pivotal year of milestones that we've had across two working groups within the R Consortium. I'll be speaking for a few minutes about the R Submissions Working Group that you've heard mentioned in previous talks this conference. And then I'll turn it over to Alex and Rich shortly thereafter about the R Tables for Regulatory Submissions Working Group progress. So let's next slide, please. Yep. So I believe most of you are familiar with the R Consortium by now, but it never hurts to set the stage here. It's very important to note that this is a nonprofit organization, but has core mission is to provide tremendous support for the R language, then through the R Foundation and community initiatives all in one. And the biggest values you see or the biggest impact you see are the grants that are given to specific working groups or specific projects to improve the infrastructure of our and the overall ecosystem. And they have a tremendous blog as well where you can keep up to date with the latest happenings. They often put spotlights on really influential community members. And again, just tremendous value that we've seen in its history already. Next slide, please. And so, like I said, I'm going to be speaking about the R Submissions Working Group, which, again, I want to emphasize the cross industry and cross collaboration with regulators as really being the life of this working group. We have been able to have successful pilots, which you're going to hear about shortly, where we want the overarching goal is to evaluate a clinical submission package that's produced entirely in R for analysis programs, analysis results, data sets, and yes, even pushing the envelope with interactive applications. But through these pilots, we really want to see where are the gaps, where are the solutions needed so that we can inform the rest of our life science partners, life science community here on the best practices and the issues to watch out for, but also getting almost, I'll get to this later, the collaborative nature with our regulators to bring that feedback into these pilots as well. But again, like the R Consortium itself, everything is in the open. We have a link to the GitHub repository organization where all of our repositories are under, where you see the full spectrum of development. Next slide, please. So the foundation is actually what you've actually heard about in previous conferences, such as our pharma. And in fact, in November 2021, now a couple years ago, this set the stage for us. We had a successful R-based test package that was submitted to the FDA, which met the requirements that we see in typical clinical submissions, such as following the ECTD specification and then supplying a very detailed analysis data review guide, or ADRG, if you're familiar with that acronym. Now, back then, we were, at least at the time, thought we were required to convert all of our R scripts to text files via package light, but I'm happy to say that's now a thing of the past. More on that later. But now with this pilot, we also made sure we used R to create all the typical tables, figures, and listings that you would see in a mock submission. And again, if you want more details on that, we have a link to the recording from last year's R Pharma where Ning Lang and Huisu Choi gave a great presentation about Pilot 1. Next slide, please. But why stop there, right? We're all big fans of Shiny. We've seen Shiny transform our industry. So we thought, why not take those results from Pilot 1 and surface them into a Shiny application? You heard about this earlier in the conference, but to recap the structure of this, it took all those analyses from Pilot 2 and then bundled it into an application as an R package. At its core is Shiny modules with dependencies that were managed by RM so that we could create that R package reproducibility on the reviewer systems just as easily as we had on our respective development systems from us on the working group. And then this ADRG took most of the material from Pilot 1, but then yours truly put in pretty precise instructions to execute this application, bootstrap it from the ECTD transfer, bootstrapping RM, And then at the time, we also use package light for this. So unbundling all those programs from the text file and then restoring the package library so that they could run the app locally on their Windows machine. Certainly, in the hope is in the future, we can have a more optimized approach for Shiny app delivery. But this set the stage where I'm happy to say that as of last month, we had a successful completion of this pilot with our FDA reviewers. Their feedback was tremendous throughout this whole process. And in fact, let's talk about some of the biggest feedback now in our next slide. Next slide, please.
Yep.
Awesome. So with Shiny, we get tremendous power at our hands for letting the user customize, say, the data sets that they're looking at, the types of results they're looking at. And in fact, in an earlier version of the Pilot 2 app, we included more dynamic data filtering. In this case, we were powering the filter modules with the teal framework and specific modules within that, so that the reviewer could easily see what happens when, say, they have a different level of age in the population or a different lab measure value. The initial version applied these filters to the source data sets for all results, including the results of statistical models that were specified in the ADRG, but it would, just like anything in Shiny, update all results, including p-values dynamically. We have found out, and this is very important feedback, that exercise for those results that were, or those analyses that were pre-specified, if there are changes, could lead to potential confounding and confusion or misinterpretation if they led to subgroups that were not pre-specified for that particular analysis, say a regression model, linear mixed model, whatever have you. But we found a great middle ground is that we have a visualization in there, a Kaplan-Meier plot, which only allows we only allow filtering in that module because we're not doing inference on that. It's really a time to survival of an event that's specified in that analysis plan, but that still takes advantage of some of the great features that Shiny can bring us. So I think there's more to this story coming in the future, but I think us as a community leveraging Shiny and interactive applications, we need to make sure we use it responsibly. But with that said, this pilot was an excellent way to surface this issue front and center for all of us. And then my last slide to conclude is where we're going next. We have a new frontier. You've heard about this a little bit. Pilot 4 is looking at a way to share this same Shiny application, but in a more efficient manner using two novel technologies. One, based in container technology. You may have heard about container orchestration engines like Docker. That gets a lot of the mind share. But in essence, a container is a way to encapsulate both the application dependencies, but also the compute environment. And it's managed by a container runtime. So it's not a full-blown virtual machine. It's more of a container and an image. We're actually using the Podman container image orchestration for this pilot because there are some licensing concerns with Docker at the moment. So Podman is open source, and that's where our regulators, colleagues at the FDA, are now going to be trying using Podman to take our application and see if they can run it in this more efficient manner. But wait, there's more. WebAssembly. This is the new frontier, the really new frontier, extremely high moving, fast moving, I should say. But we have a lot of excitement, us as a community, but also equal excitement on the regulatory side as well, where imagine an application is just run in their web browser, eliminates so much of that overhead that we had to have in Pilot 2 for bootstrapping that application. We are not there yet, but we've had significant progress thanks to our partnership with Absalon, who's made tremendous contributions in this space, as well as Posit's George Stagg, who's been a heavy consultant on this. And we hope to have results for this to be shared next year and maybe paving a way for new innovations in the submission space. We could go on for hours about that, but no, that's not the only working group we want to hear about now. So I'm going to turn it over to Alex and Rich to talk about the table submission.
Thanks, Eric. That's really exciting stuff. Love following all the different things you're doing in the pilot group. It's like, I can't believe you're up to 4 now. Things are moving so fast. Anyways, we're going to talk about our group, the R Tables for Regulatory Submissions Working Group. Bit of a mouthful. What I usually do is just remember RTRS. So it's easily searchable on GitHub. We're there, so you can find us. And who are we? So we're basically a bunch of people from different pharmaceutical companies and also table package developers. We're all meeting together and we're trying to solve this problem. Like, how do we efficiently create tables for regulatory submissions? There's a lot of our packages that work with tables. So what we've done is we looked at all of them and we tried to see which ones are most effective at doing this task and creating documentation. So our goal is basically to demonstrate and clarify the various aspects of table creation using R with a select number of packages. And we believe that this enhances the ability for table creation with R if we have all this documentation at the ready. So the what is that documentation? And why? I'm going to throw it in there. It's super useful. If you don't have this, you just sort of like, you don't have the guidance you need, I think. So it's really great to have this. Next slide, please. So we actually created a book. That's one of our initiatives. It's a tables ebook and it's published online and it's available now. It's called Tables in Clinical Trials with R. And what it does is it contrasts table creation with 7 different table R packages. Again, there's more than that, but we sort of like whittle down the list to that short list of 7. And we have a whole bunch of example tables with 5 different table types in there with all the different packages. So we can really see, you can sort of compare across the different packages and see which one suits you. You can just, take examples and run with them. And with that, we have a detailed discussion that goes with it for things like topics like formatting, pagination. And we wrote this book using Bookdown. So of course it's available online. And the great thing about Bookdown is it includes runnable code. Like it runs with the building of the book. So you can just copy and paste that code and adapt it to your own solutions. So it's available on that site. It's a little hard to find, but this link will be there. rconsortium.github.io and then rtrs-wg. Again, search for a GitHub if you like to. It's linked there as well. Just look for RTRS on GitHub. And next slide, please. The thing we're going to show next is a walk through the book. Alex will take that away and just like introduce us to different parts of the book. It's going to be so great.
Yeah, absolutely. I have to reshare, unfortunately. Sorry about that. Share the screen. Oops, sorry about the cat.
Your cat loves tables. We know that, right?
Yeah. He was part of the writing, so I think it's fair for him to have his presentation here. So yeah, this is the book. I hope you can all see it. I have the pleasure to walk you through what we've done. So basically, we're starting with a little bit of introduction, like why we've put together that exercise, and Rich has alluded to that, so I'm not going to repeat that. On the left-hand side, you can see all of the 7 tables or table packages that have contributed to this exercise. So we have GT, we have R tables, we have combination of turn and R tables. There's flex table, T format tables, tidy TLG. These are the 7 ones. And we start actually with a little bit of methodology and background. Like here you can see in the titles and footnotes section how to add titles and footnotes to an existing table. And you can take that code and compare, for example, GT to tables. And this is the code that shows you how to add the title and footnote to a tables object, which is pretty amazing. We go to the rendering tables section. Then, like, what do we see here? It's, of course, a table. So we love tables here. And it's a great overview of what output formats are actually available to you with each of the package options. You can see here, they pretty much can all produce HTML outputs, which is amazing, right? HTML is a great format, and I would love to see that used more prominently. If you want to go for PDF, then everything but tidy TLG will work for you. Likewise, if you want to render to RTF, everything but tables will work. But if you would like to go for something more exotic and maybe render to PowerPoint, then Flex Table and R tables are your only options of choice. But let's look into clinical tables now, because that's why we're here. Let's start with demographics and have a look at R tables first. This is the R tables code. You can see we've written that book in Bookdown. So you can click on the right-hand side here, highlight the code, copy and paste the code to your own console, and rerun everything. All of the code examples use the same underlying data sets, and the data that we're using, for example, here it's the X80SL data set, they follow Atom standards, so it's super applicable to our use cases. But let's look into R tables here. The majority of the code is actually composed of two helper functions, one for the numeric summary and one for the factorial summary. And then what Gabe, the package author of R tables, does is that he creates a layout. That basic table function here creates that layout with the title, subtitles, and footer applied. Columns are split by values in the ARM column. And then we analyze variables age, sex, and country, depending on whether they're numeric, or factorial. This only creates the layout. The resulting table is then created by applying that layout to the X80SL dataset. And this is what we see. So this is the standard demographic table that you would expect, right? It has the 3 columns for the 3 values in the ARM column, the drug X, placebo, and combination therapy. And we see that we have a numeric summary for age and factorial summaries for sex and country. You can now compare that code to GT and see, okay, that code is significantly longer. Why is that? Not only because I've written it and I kind of like indentation a lot, and it's, yeah, it is a lot, but also because GT requires you to do all of the cell value derivation upfront, which means that you have to feed a data frame or a tuple to GT that almost has the style of the table you want to get out. And then you apply your usual table header functions and you format the values. And in the end, the resulting table looks pretty similar to the one we saw in R tables. Same underlying data is used, so you can directly take that and compare that to the T format. It's super easy to compare these. We can look into disposition quickly. I know I only have 2 minutes left. Let's look into flex table, for example. This is the code how you can, that will produce a disposition table for you. All of these code pieces here use the same underlying data again. So you can directly copy them to your console and apply and run and see what works best for you. And this is how the disposition table looks like. So comparing that again to, let's say, the tables. So yeah, to the tables package here, you will see that it's a little bit longer because tables is one of 2 package engines that do this cell value derivation for you under the hood. All of the other packages don't do that for you. So yeah, I hope I was able to convince you to at least have a look at the tables book, and yeah, please share your feedback.
That was great. And the code you wrote for GT was super excellent. I couldn't do that myself.
Thank you.
And as we mentioned before, we have a lot of people in our group that are actually the table package authors. So they were able to like personally write code. If you can put the slides again, I'll sort of like do the outro. Yeah, thanks.
Yes.
Yeah, so that's great. So what's next for this R group, the RTRS one? We're going to focus on other topics like table value formatting, pretty big topic in and of itself. Listings, it's still a thing. It's basically just lots of big tables. So that has its own sort of difficulties and solutions. Orchestration of table creation, kind of important. We're making lots of tables. Any efficiencies we gain from orchestration, that should be talked about and documented somewhere. And the final topic we do want to explore is document integration and medical writing. Sort of like this is sort of like listed in order of priority. Next slide, please. Great. Eric, would you like to go over your left-hand side? And then I'll go over my right-hand side.
Absolutely. So yeah, we have great opportunities to get involved in our submissions working group, but also for the Shiny enthusiasts out there, definitely get in touch with us for the, for going to the working group site. And in fact, on GitHub, We have a link to our submissions pilot 4, which is currently ongoing, but we also are going to be talking about next steps with the submissions working group in general very soon. So definitely get in touch with us on GitHub to get more involved.
Yeah, and for our TRS, same sentiments. Join. We meet every 6 weeks. It's quite a good group. I've been in it since the beginning. And if you have anything to do with tables at all in your work, and you're part of pharma or just a table enthusiast, reach out. We're totally available, and we'd love to collaborate with you.
Great. Thank you so much.
Thank you.
Yeah, I think that, we're right on time, but we can take a minute or two if there are any questions. I'm going to do a quick scan here. Okay, actually, I do want to surface a question from Harvey real quick on the submissions working group side. He says, it is very exciting. I agree about WebAssembly. With everything running in the client, how would you address the concern of security? So certainly keep in mind what Max Kuhn said in his talk yesterday. Whenever you have a Shiny app in WebAssembly, you don't want to pass in sensitive credentials if you can avoid it. We're definitely positioning this as a more self-contained application. The data sets are already loaded as part of the quote unquote repository that the application is being bundled with. But we have had conversation with George Stagg at Posit, who has said that actually the browser running the application is a more tightly controlled sandbox from a security standpoint than even a container such as run with Docker, which is really almost too good to be true. But we're going to keep pursuing that. But that will be a hot topic with our colleagues at FDA as we share this out further. All right. Looks like I'm not seeing. Oh, okay. We do have one more question for you, Alex and Rich. What table packages did you use to make tables rendered in that book down?
Oh, 7 of them. Yeah,
that's what I thought.
All of them.
Yeah. They all rendered
right?
nicely in Booktown. It's brilliant.
Yeah, that is the beauty of them. Like that whole book shows you. Let me count. Ooh, math is hard. We show 5 different archetypes of tables, and all of them feature 7 ways to produce them. So all of the 7 packages are covered. Check that out. It's super cool. You can lay the code side by side and choose whatever works best for you.
Terrific. All right. Well, I think that will probably wrap us up here. So thank you again, Alex and Rich, for joining me for this presentation. I'm glad we could collaborate on this. It was fun to have our brainstorming sessions for these slides. I've learned a lot more about your working group, even of that effort as well. And certainly looking forward to collaborations in the future.
Thanks, Eric.
Thanks for having us, Eric.
Yep.